So hopefully you now know what significant figures are. Okay, we've done that significant figures exercise. Now there is another wee bit just about when should you use significant figures, or sorry, how do you know how many significant figures to round to? So maybe in maths you might have been told, or you might get told to do work and round your answers to 2 decimal places, or round your answer to 3 significant figures. You maybe get given that instruction. That's not what happens in engineering science. In engineering science, the expectation is that you should know how many figures to round it to. Remember, the amount of significant figures that you round a number to basically dictates how accurate you are. So, for instance, if I were to measure how tall I was, right, and I was to say that I was 1,700 millimeters tall, okay, that's 2 significant figures. They're trailing zeros and there's no decimal point, so they're insignificant, right? So I'm saying I'm giving that figure to 2 significant figures. I'm pretty sure I could go to some, high-end scientific institute and I could get my height measured much more accurately. Yeah. There's 8 significant figures. That's a much more accurate value. Now obviously, there's 2 issues with that. One, I'm measuring my height. Why do I need to go to a scientific institute? 2, we're measuring this to, what's that, 0.1 of if that's millimeters, then that's micrometers, 0.1 of a micrometer, right? How thick is my hair? You know what I mean? It's like, how much would a breath of air on my hair affect that measurement because of how accurate it is? If there was a little bit of wind, my height to 8 significant figures would change. So there's an issue about how accurate do you need to be. There's a thing about NASA where they talk about, you should be familiar with pi, yeah? So, why am I doing that when I've actually got a circle tool in here? Try to freehand a circle on a computer when I've got an actual circle tool, right? So there's a circle with the centre and a radius attached, right? So there's a radius, and the circumference, you can calculate the circumference of a circle by multiplying the diameter by a value called pi. And pi, as you can see, is calculated by the circumference divided by the diameter. So if you take the circumference of any circle and divide it by the diameter, you will arrive at this number, and it starts off like that, 3.141, and then very famously it's an infinitely long number with no recurring digits in it or whatever. You know, it's I don't know how to describe it, I'm not a mathematician, right? But basically it's a super long number, right? And you can calculate that to lots and lots and lots of significant figures or decimal places. And very famously, NASA use pi, you know, they reference pi in a lot of their calculations, but they only use it to something like 5 significant figures because they say there's no need to go any more accurate than that. Now, a lot of what I've said there might be apocryphal, or they might have got the numbers wrong or whatever, but it's along the same lines, and it's the same lines as me measuring my height example. How accurate do you need to be? You need to be able to answer that question for different contexts, but there's a dead easy way to do it, right? If I go and look at, I should be able to go in and look at, and this will show you where this stuff is if I haven't showed you already. So if you go into the SharePoint and Glow, that takes you to the schools thing. In fact, yeah, I've shown you the data book, haven't I? The data book's on the files. It takes you a wee table of contents, and we've got engineering science down there. Just get rid of that. There's the engineering science page. You should bookmark this page, because this is where all of the, see in the documents tab, this is where all of the notes, all of the assignments, this is where the copy of the data book and past papers is. Let's get a look at some of these past papers just to show you what I'm talking about, right? About when to round to the correct number of significant figures. So I got in level 5 by topic, and we have a wee look at I'm going to look at the energy one because that'll have probably the biggest concentration of maths questions in it, right? Right, so see this question here. Oh, what's happened? Let's zoom into width. Down, down, down. Right. Determine the potential energy of 2,700 kilograms of water held at 12 meters above the turbine. So you need to do a calculation in there. Now, we haven't covered any of this stuff yet, so don't worry. I'm just going to rattle this out because it's good for you to see the kind of standard, right? So if I stick this in here, so there's the question there. What would the answer to this look like? So I'd look in my data book and I would find, if I didn't remember it, I'd find that the equation for potential energy is mass times gravity times height. Gravity is given in the data book as well. So I've got a mass there, I've got a height here, all I'm doing is plugging the numbers in. So 2,700 multiplied by 9.81 for acceleration caused by gravity, multiplied by 12. 2,700 multiplied by 9.81 multiplied by 12. Don't worry that you don't know what potential energy is, or I haven't talked about it. 317,844, 317,844, and the units are joules. Okay, so that would be the raw answer. Now, at this point, this is where you have to round it. And we're going to round it to significant figure value. How many significant figures do we round it to? And the rule is, you know, how accurate are you going to be? So your answer can only be as accurate as the least number of significant figures in the data given. So the data that you used and the data used, we'll say. Yeah. So this value's got 2 significant figures. This value's got 3 significant figures. This value's got 2 significant figures. The least value of all those 3, 2, 3 and 2 is 2. That tells me how many significant figures to round it to. I've got to round this to the least that I'm given in the data. So this has only got 2 significant figures. This has only got 2 significant figures. I need to round this to 2 significant figures. So my final answer, as stated, would be, so that stays as a 3, and that's going to become a 2, 3, 2, that's going to become a 0, 0, 0, 0. That's me rounded that value to 2 significant figures. Because the data, 2 significant figures, 2 significant figures. If this only had 1 significant figure, if that was given to me as 3,000 kilograms, then I need to round this to 1 significant figure and it would be 300,000. If that was 3 significant figures, and if that was given as 2,750 kilograms and that was given as 12.0 meters, they're all 3 significant figures, and 9.81 would be 3 significant figures. That means that's, we've rounded to 3 significant figures, so it would be 318,000. So that's how you know what value to round to, how many significant figures to round to in a question, the least amount of data given. So what I'm going to do now is, I'm going to stick some questions in, right? I don't want you to do the questions because you don't know how to do the questions yet, but what I want you to do is to state how many significant figures you would round to. So just like I've done, looked at the data in the question and I've said, right, that's got 2, that's got 2, the least that is 2, that means I'm rounding to 2. So, for instance, I'm going to stick a bunch of questions in, and what I want you to do is tell me how many significant figures are in that, 2 significant figures, tell me how many significant figures are in that, 2 significant figures, and then that means that I round answer to 2 significant figures because it's the least value. I'm just going to put another bunch of questions in there and I want you to do exactly the same thing. See if you can arrive at the correct number, the correct rounding value. Give me a second. Right, so there's a handful of questions there, okay, so there's like your question 1, question 2, question 3, question 4. So all I want you to do is tell me how many significant figures should you be rounding your answer to in question 1. And it's that same process. Identify the amount of significant figures in the data in the question, compare those numbers and find the lowest one, and that's how many values you should be rounding your answer to. Right, so check that out.